Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 14th, 2025, which was about 4 days ago. The headline result is striking. By quantizing and caching the layer inputs and rematerializing keys and values on the fly, the method delivers up to around 7.7 times memory savings, with less than 0.1 perplexity degradation. The paper is titled XQuant, Breaking the Memory Wall for LLM Inference with KV Cache Rematerialization. And as we will see later, the implications for real-time decoding are compelling. The authors also unveil a cross-layer variant that reaches 10 times and even 12.5 times savings with minimal accuracy loss. Alright, this chart compares memory compression on the horizontal axis with perplexity degradation on the vertical axis, so the best region sits toward the top right. You can see the red points for the cross-layer method hovering near the top right, indicating 10 times to 12.5 times savings with tiny accuracy loss. Building on that, the green points for the base method push far right with low bits, trading a bit more degradation for big compression, while orange and blue baselines drop downward as bits shrink. Next, let's zoom into the side-by-side schematic. On the left, the standard KV quantization stores both keys and values, which drives many memory operations per decoding step and keeps compute roughly fixed. On the right, the approach caches only the input X, then recomputes keys and values from X and the projection weights, which doubles memory efficiency while adding extra math. The green labels emphasize fewer memory moves, and the note on the right highlights 2 times memory savings overall. Building on the schematic we just discussed, this diagram walks through cross-layer compression during decoding. The green blocks show the approximated inputs, starting with X0 in higher precision, then X hat 1 and X hat 2. The small green boxes beneath each indicate the quantized deltas that get cached. The blue arrows and plus signs illustrate how the accumulator adds the latest delta to the running sum, so reconstructing layer I only needs the accumulator, and one new delta, not all prior deltas. Okay, this table reports perplexity and memory for 4 models, split into 2 blocks, multi-head attention on the left and grouped query attention on the right. Focus on the shaded XQuant rows, which match or beat KIVI star at the same memory. For Llama 2, 8-bit XQuant keeps baseline perplexity while using about 1/4 memory. Moving to lower bits, 4-bit and 3-bit deliver 5 to 10 times savings with small degradation. On grouped query attention, 2-bit still outperforms KIVI star at equal memory. Continuing from the results, 2 takeaways stand out. First, caching input X and rematerializing keys and values reliably shifts the bottleneck from memory to compute, delivering big savings with near baseline accuracy. Second, the cross-layer variant squeezes memory even further by delta caching. That is it for the AI Research Roundup. I am Alex. Thanks for listening.